So welcome back. We are now looking at section 7.4, and you notice this is confidence intervals and sample size for proportions. And so back in 7.1 it said we could do confidence intervals for means, and we could also do confidence intervals for proportions. We just went through 7.2 and 7.3 finding confidence intervals for a mean when we had the population standard deviation and when we did not have the population standard deviation. So this is basically the same thing, except we're now going to do our calculations for proportions. I'll read along on some of this. You can read along and underline. But remember, with what we're doing, you need your formula card, you need your calculator, you need note paper, sticky notes, index cards, highlighters. This is where you're replicating that we're just like we were in class. One of the most common types of confidence intervals is one that uses proportions. In this section, you're going to learn how to find the confidence interval of a proportion. And so it mentions USA Today and says there's a parameter 12%, and that in that article, that's what we're calling a proportion. A proportion represents a part of a whole. I would underline, highlight, sticky note, do lots of stuff, that a proportion's just a part of a whole. Oh wait, it's just a fraction. Oh, that's all we're talking about. It can be expressed as a fraction, which we can turn into a decimal, which we can turn into a percentage. In other words, we could call it 12%, or 12 hundredths, or 12 over 100, or we can reduce it. Proportions can also represent probabilities. So in this case, if a pleasure boat is selected at random, the probability that it is called serenity is 0.12. So there are some symbols. You've seen these before for the most part. But just to go ahead and go over those and get them in our minds, P is going to be the population's proportion. Okay. P hat, which is red, P hat, is going to be the sample proportion. So underline those, highlight those, soak those in for a minute. So, stop the video, think on these. Proportion for the population. P hat is the proportion for the sample. Then they give us a couple of little formulas which would make sense, part to whole. It's going to be, as it says here, P hat is X over N. They go ahead and tell us X is the number of sample units that possess the characteristics. We've done these kind of things before. And then the N is the sample size. So P hat is the sample proportion. But we also played around with, well, what about the other part, the part that's not the sample proportion? That's Q hat. And we're going to take 1, which represents one whole, or 100%, and then we'll subtract off P hat. There's another formula where we could take all of the X that we want and put it over the sample, or the sample size. And, well, we could also take the sample size, take off the parts that we want, that'll leave what we don't want, and divide it by the sample size. This is good, but I bet these are the two you use the most. We'll see. And so moving over to an example. I'm at the top of 383, and at the top of 383, I'm going to focus this thing again. It's not exactly, that's a little better. In this example, it's talking about assault victims and says there is a random sample. Ding, 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 ding. We got a sample. And the sample has a total of 150 assault victims. And you might start writing yourself notes like, this is my total, or this is the N. It's the total amount in my sample. And they found that 45 out of that 150, so like 45 out of my 150, they took no self-protection actions against a criminal. They want us to find P hat and Q hat, and then they have to tell us which one's P hat. It's the proportion of victims who took no self-protection. So how many took no self-protection? 45 out of the 150. So I'm going to jump down here to where they've already got it worked out. P hat, it's the part that we want over the total, the whole. So 45 out of 150, we can divide it. We can have it as a decimal. We can move it to a percentage. We could reduce this fraction. You need to be versatile to leave your answer in multiple ways. I don't think they told us how to leave the answer, so we got to be ready. You can leave it how you want to if I don't tell you on a test or if they don't tell you in the homework. But they want not only P hat, they want Q hat. Well, I'm all about lazy, that if I already know this is 0.3, I'm going to jump down here and just do 1 minus 0.3 and get 0.7, or 70%. But if you're not feeling lazy, and you want to go ahead and say, well, out of the 150, let's take out the 45 who did not use self-protection, and that'll leave 105 who did use self-protection. These are the ones who did not. These are the ones who did out of the 150. And when you divide 105 divided by 150, you get 0.7, or 70%. So it doesn't matter which way you go at it. You just need to stay oriented with which one's P hat, the quality we want, and then the other, the one we don't want, is Q hat. As with means, the statistician, given the sample proportion, tries to estimate the population proportion. We are looking for P. But, as with the means, one is not really able to decide how good our little estimate's going to be. So therefore, statisticians also use an interval estimate, just like what you've been doing. It might have a few different pieces and parts, but it is just like what we've been doing. But this time we're doing it with and around a proportion. And they can assign a probability that the interval will contain the population proportion. So, no shocker there. We're going to use like, oh, we want 90% confidence. Or, and then we'll fill in the blank. So if I was in class, notice we would just go to the example. But we're not in class. So we're going to go down here and we're going to look for just a second at confidence intervals. We got to use the margin of error. No shocker there. That's the symbol for margin of error. And then we've got the Z sub A alpha divided by 2, or alpha over 2. Wow, that looks familiar because it is. Square root of, well, looky there, P hat times Q hat. Hey, there's our new part. I can do that. I can tell you what P hat is. I can tell you what Q hat is. I can divide it by the number in my sample, do all my little square root timesing and stuff. I even know how to already find this Z sub alpha over 2. But I do point this out because if some of you are going on to another stats, and I know some of you are, you'll later have to make sure that these criteria are met. I had to do it in my dissertation. But for what we're doing right now, it's going to be met. It's rigged, if you will, for our book. There is a formula, and you need to be grabbing your formula card because we are still in Chapter 7. And then if you look down here at the bottom on Chapter 7, where did he go? Here's this. Wait, what's going on here? Here it is. Confidence interval for a proportion. Here's the big old ugly formula. No big deal. We've got the error, right here. Confidence interval for a proportion. That's what this is. Again, no big deal. And I see Tiffany every time I say that. She's like, you make it sound so easy, because it is. So over here, I don't even like the negative side. We'll go over here to the positive side. We'll cover all this mess up. You're going to need to calculate P hat, Q hat, times, divide by n, square root it, and multiply in whatever they're asking on the Z for us. And you're going to get a number. And then you're going to take a number, that number, and you're going to add it back into P hat, and you're going to put that number on this side. You're going to take that a number that you had, all of this P hat, Q hat, over n, square root Z divided by, or Z sub, alpha divided by 2. Get that same number, but now you're going to take P hat and subtract that off, and that's going to get us our confidence interval. They reiterate here, we're supposed to have some criteria. It's going to be met in our book. There's one more comment I'd like you to see before you head off to the video. Rounding rule for the confidence interval for a proportion. Round off to 3 decimal places. I know Connect Math may do one thing. I may ask a different thing on the test. What you're doing in here, who can say? I would just suggest that you don't round and then round and then round and then round. If you do round early, that you do round off to 3 or 4 decimal places. And do the 3 or 4 decimal places often. And then when you come down to the end, then round to what's being requested. So you notice right here it says you're going to go to a video. That's going to be the next part in the lesson. You're going to go to a video that came with Connect Math. And then you're going to keep working through the rest of this section. So another reminder, y'all be safe. But this finishes the introduction for section 7.4.